In this video, we're going to look at the small angle approximations for all three trig functions, where they come from, and how to apply them to a question. First of all, the small angle approximations are given in the middle of the board here. So you can see sine theta is approximated just by theta, cos by this expression, tan by this expression. And these approximations are only accurate if theta is small and measured in radians. People often ask, what do you mean by small? Well, the best way to think about it is the closer theta is to 0, the better this approximation will be. To see where these approximations come from, we're going to focus on the approximation for sine. So just theta. Sine can actually be rewritten exactly as this series at the top. It may look a bit random, but this is called a Maclaurin expansion. You can apply Maclaurin expansions to a lot of different functions, including the three trig functions. And it's just another way to write the function, but as an infinite series. So this is true for any real number. So take some value theta. If I put it into sine, it's going to return a value. And if I take that same theta and put it into the series on the right and keep adding the terms forever, I'll get the same value as the sine of the angle. So that's what an infinite series is. Okay. And sine actually equals the right hand side. This isn't an approximation. Now, think about what happens if theta is small, very close to 0. If you look at the infinite series, some of these later terms are going to be extremely small. If theta is a fraction, say 1 over 100, then if you put it to the power of 7, you're going to have a very, very small number. Well, this is going to be very small as well, and even if you cube 1 over 100, you're going to have a very small fraction. Which means these later terms aren't really doing a lot when you add them on. It's kind of, if theta is small, the first term here is most important, because the other terms are they just get so small compared to this first one. You could say they're negligible. So when theta is small, in fact, sine theta is roughly equal to theta. And we can, they're having such a small impact, these later terms, that we can not worry as much about them and just take into account that first theta. So that's where this has come from. And you've probably observed the same thing is happening for cos. If you write an infinite series for cos, it looks like this, and it's equal to cos theta, not approximated. Again, if theta is really small, these later terms aren't doing a lot, and you can kind of just take into account these first two terms here, which we have, and the same for tan. So that's where they're coming from. There's another great way to see where these approximations come from, and that's by sketching the graphs of the left and the right. And you can see that when theta is very small, the behaviour of the curve on the right is the same as the behaviour on the left. And then as you move away from 0, kind of, you get your sine wave, and the approximation's awful. All right, okay, let's apply it to a question. Have a look here, example 1. Show that this expression here can be approximated by this when theta is small and measured in radians. That's crucial, because theta isn't small or isn't in radians, these don't apply. Okay, but it is here, so let's go. All right. So we can kick it off writing out our trig expression. All right. And then you simply just use the three formulas. You get them in the booklet, which is great news. So first of all, it says sine of your angle is roughly equal to the angle. So sine phi theta will be approximately 5 theta. Tan 2 theta is going to be approximately 2 theta. And minus cos 2 theta. Minus, well, the cos approximation says cos of your angle is roughly 1 minus the angle squared over 2. The big mistake everyone makes is this. I haven't actually followed the rule here which says the angle must be squared and divided by 2. My angle's 2 theta. I must square it. All of it, not just the theta part. Okay, and then we're just going to tidy this up and we'll cross our fingers we get what's on the right hand side. Alright. Okay, so we get 7 theta. There we go. Okay, so that's 2 theta squared. There we go. All right, we've got the right hand side. All right, question 2. This won't take us 2 seconds. Hence state the approximate value of this expression when theta is small and measured in radians. Okay, well, if theta is small and measured in radians, this here can be approximated by this. So that's really what we're dealing with. And if theta is very small, so it's approaching 0, these first 2 terms will also be very, very small. Which means this expression will roughly equal -1. That's really the only term of any significance. And that's it.